A key ambition with this fish feeder was to blend in with the surroundings, so the fence that it's around. So if you're behind the fence, you almost don't see the fish feeder. And here I'm feeding out some pellets, and yeah, the fishes are hungry always during summertime. And you can also see that one positive thing I think is that it's not sensitive to have the plants around it, so it's a bit more exciting for the fishes there to collect the food, and it takes a bit more time, and it doesn't go into the skimmer too fast either, that is on the opposite side of the pond. So yeah, it's working really well, and it has the food for almost a full season in it. Here are the parts for the fish feeder, and there's a few 3D printed parts, but then also standard 70mm sewer pipes, and this is used as the container for the koi pellets. It's, yeah, you can paint it in whatever color you need. This is actually the biggest flaw of the construction, to make the colored paint job to stick to this PVC tubes. That's the trickiest part. So it's manageable, but you have to rug the edge and the surface here before you paint it, and probably have some. It would be good to have some kind of primer first, also, I think. So this is gonna slide into here. And that's how it gets in contact with the feeding device. And the other parts here are, I'm mounting this next to my garden pond against the fence. That's some that I had around have around my pond, and it's roughly 1 meter high. And this is just a mounting to be able to clamp it towards the fence. So this is going around the pole of a fence, and you just add 2 screws on the side here, and when that clamps here, it will make it sturdy. Yeah, it's a regular pipe here, and yeah, lots of space for the pellets, and it's a very convenient way to top up the pellets also. And then it's just a lid to be top on here. Then for the actual construction of the feeder is centered around this screw. You can see it. Yeah, it's like a pellet screw, and the hole here is not a very tight fit. Here you can see it can wobble a bit, and I used to have a very tight fit with the screw. I thought that it would be best, but it's actually turned out to be better to have a few millimeters around it. Otherwise it makes more noise, and you got more crushed pellets also. So here it's keeps a very nice and clean, and you don't get any debris or powder from the pellets. To drive this, it's a simple DC servo, like a $10 or $15. It's a continuous rotating servo. And this is FS5103R I'm using, but I've tried several other DC servos, and they have all done the job. And then the actual controller for this is just a VMOS D1 Mini. So it's hooked up over Wi-Fi, and it doesn't have any logic in it with timeouts, etc. So it just acts on when you have it connects to the local MQTT server, and then listens to any commands there, and sends a confirmation back when it has fed a certain amount. So really no logic built into there. Yeah, you see us here, I've just pulled a cable, so this is how it comes out from the feeder, and you just mount it like that. Just have a few screws here that you attach it with. Another good aspect with this is that you have a very easy access to the feeder, and I mean I haven't had any problems with this, so I haven't had time to, or haven't had to open it very often. But this is the way that you access it, and you just screw this on top, and then, as I said, the pipe will be you slide it all the way up until this edge here. So this is the only part that is out over the water, so to say, because you pull the pellets from up here, and then it ends up down here, and so this part obviously needs to be outside of the edge of your pond. If we open it once more and pull the power, so now it will connect to the Wi-Fi and to the MQTT gateway, and I'm going to show just how it works in practice here. And here we have the web GUI for the application, and yeah, you see the other stats, but you also have a feed button, and if you press that one, yeah, you will see that it will have some predefined number of steps that it will take, and you can continuously do like that, but normally you would use then timers that you just program and set a daily feed rate and amount and so on. So you give amount in milliliters, and then it just does the job for you. This is the model for the fish feeder. So there's a lid and the sewer pipe. So these are standard sewer pipes, and I think that the reason I wanted to have this was both to blend in with the fence, and also to have a big tank for the pellets. I mean, this is way beyond what I use for one full season. But still, it's if you have a lot of fish, then it's good. And the height is also suitable to top up with pellets and so on. And of course, if you want to reuse this kind of construction with some other kind of tank, that's also possible. Or just the idea. I think if we remove the lid here, we can more easily see I mean, you saw in the previous video how the pellets are being pulled here, and there's very little force inside here. If we take a look at a section analysis of this, there's not really a super tight fit for the screw. Like I mentioned, there's probably a few millimeters on every side of the screw here. There are no pellets that are gonna just come out here anyway. And that it's tight enough for that, but by this we don't get any waste, and there is no clogging or anything like that when in the parts that, I mean, this is the only part that is being exposed to the water, and I thought there might be a bit more water coming up here when it rains or something like that, but yeah, it's been working really well. So I've had this out now for 3 seasons without any failures or anything, like no debris in the pellets or so. When it comes to the programming of the fish feeder, it's running on this WMOS D1 Mini, and this one connects over your local Wi-Fi. So at least you need to change the credentials and the SSID to match your local Wi-Fi. Another aspect of this is that you can program it using the Raspberry Pi, where you already might have set up platform IO to be used to program the Arduino Uno and the Nano here for the quality and the control circuits. There's a bear in mind then, if you already have this board connected, then the WMOS D1 Mini will probably get another index of it. Otherwise, then these ones will compete of the same name. And this is something that you only have connected for a very short time when you're programming it, and then you will never have to touch it again. Now we are at the top of the Poseidon repo, and you have the Fishfeeder folder here, which we go into. So now we're just going to change the values that we need to change to program it. You have the command file here that you can source, and there's already a platform IO set up here. There is a note in here that says, like I mentioned before, that you can get the conflict here. If you already have an Arduino Uno plugged in here, you can get the same conflict in name. So then you need to change maybe this ACM 0 to 1 instead, and then to be able to program it. But I mean, you will notice that, because otherwise you would get conflicts that it's the wrong type of device, etc. So it won't go unnoticed for sure. If we go down into the source folder, you have a file called credentials, and you can't really miss it either. You're going to get the error here saying that remove this line once you have updated the values below. So yeah, just remove it once you have updated it. So your SSID is like your name that you have that is broadcasted on your Wi-Fi, and then there's the password to log into it. So you need to change that, and then we go into the main.cpp, and you need to change here. It could have been better, but this is I'm assuming that you're running this on your local network, so you need to enter the IP address of your Raspberry Pi, and preferably you should have a fixed assignment to that Raspberry Pi, so it won't be moving around on any IP addresses. Otherwise, the only software that it does really, it connects to the Wi-Fi, and it listens and it connects to the MQTT gateway that is on this IP address, and then it will basically just be waiting there for actions and handle reconnects and so on. But then you will get some feeding command sent from MQTT, and it will handle the pulses out to the DC servo, and then, because there are some timings, you need to wait for a certain time. That's the way you control both the direction and the speed of which torque you're going to run the DC servo on. And then it will provide some feedback back also when it's ready. So yeah, that's basically it. And there's some periodic reporting of the RSSI, the signal strength, and so on. So some other stuff, but it's nothing that you really have to bother too much about. So just change those values in the top. Now we have seen most of the Fishfeeder in action, and thanks for watching.